Hello students, welcome back to Mathfish Java programming tutorials. In this video, I'll discuss matrix multiplication program. The contents are introduction, understanding matrix multiplication program, the program in the Java environment, and practice exercise. Matrix multiplication produces a third matrix from two matrices. But there are a couple of rules over here which we need to understand to write the program. Let's assume first matrix is with the order 2 by 3. Any order it can be. 2 by 3, A by B. Then the second matrix must start with 3, that is number of rows 3, by any number of columns. A by B, B is number of columns in the first matrix, and B by C, B is the rows in the second matrix. 3, 3, common, must be there. Number of columns in the first matrix must be equivalent to number of rows in the second matrix. What is it? Number of columns in the first matrix must be equivalent to number of rows in the second matrix, A by B, B by C. Now coming on to third matrix, it must be A by C. A is 2 for the first matrix, number of rows. C may be 2, 3, 4, 5 in the second matrix columns. Now the third matrix must be A by C. You remember the Pythagoras theorem, AC square is equal to AB square plus BC square. Here no square root, but AB, BC, AC. What is this A? Number of rows in the first matrix followed by number of columns in the second matrix. AB, BC, AC. The order or the size is different for each matrix. If we understand this much, we can write half of the program. Please remember, order is AB, BC, and AC. With this understanding, let's see an example. First matrix, 2 rows are there, 3 columns are there, A by B. Then second matrix, B by C, that is 3 by 2, 3 rows, 2 columns. And third matrix is of size A by C, that is A is 2 in the first matrix rows, and C is the number of columns in the second matrix, A by C. The next example, the first matrix has 3 rows and 4 columns. So 3 by 4, A by B. According to the rule, the second matrix must contain BC. B means rows over there. B, 4 rows. 4 rows, 3 columns. 3 or 4, any number of columns. But rows must be equivalent to the columns of first matrix. Now the third matrix of size 3, 3, AC, 3 by 3. Now what we do in the third matrix? How do we multiply? There is a formula for this. The formula is first row, multiply or add whatever it may be, and first column of second matrix. The answer will go here. Again, the first row and the second column of the second matrix, answer will go to third matrix in this area. Over here, second row of first matrix, and first column of the second matrix. Multiply, add, we will see that part in the next slide. Now you can guess second row and second column, second row of first matrix multiplied or add, whatever it may be, column 2 of second matrix. Now what do we do? 1, 2, 3, 10, 30, 50. We said in the first one. What do we do? 1 multiplied by 10 plus 2 multiplied by 30 plus 3 multiplied by 50. In this area, first row, second column, that is 1 multiplied by 20 plus 2 multiplied by 40 plus 3 multiplied by 60. Similarly, the next row of the third matrix will be 4, 5, 6, 4, 5, 6 in both the places. But in the first part, 10, 30, 50, then 20, 40, 60. Answer would be this answer. The next example, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4. 4 rows are there. So, in the first row, 1, 2, 3, 4 only, but 3 columns. Then 5, 6, 7, 8. 3 columns. One is this column, second column, third column. Then 1, 2, 3, 4 again. First column, second column, third column. This is the answer. Now let's understand the program. First part is reading size of matrices. That is A, B, B1, C. We know that first matrix AB, then BC only, but we will ask the user and we compare B is equivalent to B1 or not. That is, number of columns in the first matrix are equivalent to number of rows in the second matrix or not. So here we'll ask enter number of rows and columns of the first matrix. A, B are read. Let's suppose 2 by 3. Then enter number of rows and columns of the second matrix. B1, C are read. If B1 is 3 and B is 3, no problems for us. Otherwise, we'll check first of all. If B not equal to B1, matrices with entered orders cannot be multiplied and returned. Stop the program. Otherwise, we'll go ahead and declare 3 matrices with 2 by 3, 3 by 2 and 2 by 2. So, first matrix A, B are the sizes 2 by 3. Second matrix with the order 3 by 2, that is B by C. Third matrix with the order A by C, that is 2 by 2. So first is declared, constructor initialized. Then second, 3 by 2. Third, constructor initialized all these 3 matrices with 0. Now, we will read the elements using read method. In the previous video also we've called read method print method by sending the address call by reference. First, second are sent to read methods. AB is the size, here BC 2 by 3, 3 by 2. The matrices will be read by the read method. First address will go to A and then A of ijsc dot nextInt. A refers to first time, first matrix. Then when we call second time, A refers to the second matrix address. Call by reference. Then first will be read 1, 2, 3, 4, 5, 6. Then second is read 10, 20, 30, 40, 50, 60. How is it possible? In the first one, 2 by 3, 2 rows, 3 columns. And in the second one, 3 rows, 2 columns. So this is how the elements are read in 2 matrices. Then we need to do this calculation. We know this. But in this example, I am taking A, B, C. A is 2 rows. B is 3 columns. And C is 2. A, B, C. We must remember this to understand the program in the next slide. A is 2, B is 3, C is 2. A is 2, B is 3, C is 2. Now, actual matrix multiplication program, that is multiplication, happens with the help of 3 loops. 1, 2, and 3. The first loop runs 2 times, A many times. Second loop runs C many times. This is the proper logic. Third one runs B many times. Let's understand why and how. And every time multiplication and addition happens. How? Now when I is 0, J is 0, K works 3 times. When I is 0, J 1, K works 3 times. Then I is 1, J 0, K 3 times. Like that, if you multiply, A is 2 multiplied by 2, that is C, multiplied by B, that is 3, multiplication rules. 12 times this loop structure works. Let's understand one by one. When I is 0, J is 0, K works 3 times. First and second are the matrices. What is the statement? First of I, K we are understanding now. I is 0, K is 0, 0, 0. Then I is 0, K is 1, 0, 1. Then 0, 2. Of first matrix, 0, 0, 0, 1, 0, 2, 0, 0, 0, 1, 0, 2. Horizontally, we are accessing the first array. Then multiplied by second of Kj. What is Kj? K is 0, J is 0, 0, 0. K is 1, J is 0, 1, 0, 2, 0. So 0, 0, 1, 0, 2, 0 of second. So 0, 0, 1, 0, 2, 0 of second matrix. That is, one is horizontally we are accessing, second one we are accessing vertically. That is 1 multiplied by 10, 2 multiplied by 30, 3 multiplied by 50, and keeps on adding in sum in the innermost for loop. The sum is 220. So this 220, where do we write? In third of ij. I is 0, j is 0, 0, 0 area. Then j becomes 1. When j becomes 1, again we'll see first of I, k. I is 0 only, k is 0, 0, 0, 0, 1, 0, 2. That means from first, we are accessing horizontally the very first row, 1, 2, 3. But second of kj, k 0 only, 0, 1, 2, but j is 1. So 0, 1 is this area. 0, 1, 1, 1, 2, 1. This is 1 multiplied by 20, 2 multiplied by 40, 3 multiplied by 60, which is equivalent to 280. And we need to store in third of ij. I is 0, j is 1, 0, 1. This area. 280. So far, 6 times the loop has worked. Now I becomes 1. I becomes 1, J0, J1 again. For J0, K works 3 times. And for J1, K works 3 times. Let's go to the next slide and try to understand I is 1. In that case, these two will be populated. How? I is 1, J0, K0, 1, 2. Then J1, K0, 1, 2. First of I, K, let's understand. I is 1, K is 0. 1, 0, 1, 1, 1, 2, 4, 5, 6. And then second of Kj, J is 0, 0, 0, 1, 0, 2, 0. That is first column of the second one and then second column. So with the help of 3 lines of nested loop, then some innermost loop, then storing third of ij is equal to sum, and then reinitializing sum to 0. This is the matrix multiplication program. Now let's see the program in Java environment. Here we need to first declare 4 variables A, B, B1, C. This is for rows and columns of first matrix, and B1, C for rows and columns of second matrix. So reading order of matrices is the first task. Then checking the order, that is number of columns B is equivalent to number of rows in the second matrix, that is B1 or not. If it is true, reserve space for 3 matrices, that is with this order. First order is AB, second one is BC, third one is AC. Then read first 2 matrices called read method, then matrix multiplication program, and display all 3 matrices. So this is the program which we are aiming at. Here, scanner, then enter number of rows and columns of the first matrix, and we are reading in A and B. Then enter number of rows and columns of the second matrix, B1C. Now we have to check B equivalent to B1 or not. Number of columns in the first matrix equivalent to number of rows in the second matrix or not. If so, then it is okay with us. Then we'll write or execute the rest of the program. Now, if B not equal to B1, then matrices with entered orders cannot be multiplied. Return. This is what is cannot be multiplied. Now, this is what is check. If this is true, then returns. Otherwise, we can go ahead and reserve space for 3 matrices, that is with AB order, BC order, and AC order. Let's see. So the first is equal to new int AB order, then BC order, then AC order. First, second, and multi is another array where we are storing the multiplied values. Then comes reading first 2 matrices. Like the previous video, we'll call the read method. Reading 2 matrices, system.out.println, enter A by B elements, 2 by 3, here 3 by 2, and then read first AB. We know this already. First is sent as call by reference to A, and AB are rows and columns. So we are running 2 for loops and reading into A of ij, sc dot next int. Then the second read method, sending the address of second matrix and the size of second matrix, and again read. Now actual matrix multiplication program which we need to write over here. Now matrix multiplication in sum equals to 0, 3 for loops. First one is running till A, then C, then B. Sum is equal to sum plus first of ik multiplied by second of kj. Inner loop finished. Multi of ij equals to sum, and then reinitializing sum to 0 because we want a fresh sum for each and every row and column position. Now end of outer for loop, end of outermost for loop. This is the matrix multiplication program. Now we'll see displaying all three matrices. Instead of writing the code for display, that is 2 for loops, 1 system.out.print, then println 3 times, we call the method. This is a static method because we are calling from main. We haven't created any object over here. And then first time we are calling the first matrix address we are sending to X and AB 2 by 3 to AB over here. So call by value, call by reference. Lesson 34. We know that already. Call by reference, call by value. Link is given in the description box. First has gone to X and X is being printed. Then second address is gone. Then multi address is gone. All three matrices are printed. This is the program. Let's have a look at it one more time. See, reading order of matrices A, B, B1, C. If B not equal to B1, then print this message. Otherwise, go ahead and declare three matrices, first, second, and multi with order A by B, B by C, and A by C. Now, enter the elements reading two matrices. First one is first, second one is second. And then code for matrix multiplication. Only 6 lines over here. And then displaying all three matrices using first, second, and third as parameters. The second method other than main is display. Then third method is read. Total 3 methods are there in this program. Let's execute and see. Matrix multiplication, compile. Okay. Enter number of rows and columns of the first matrix. 2 rows, 3 columns. Then rows and columns of the second matrix. 3 rows, please remember this. And 2 columns, suppose. Enter 6 elements of the first matrix. 2 rows. I'm giving 1, 2, 3, first row. And then 4, 5, 6, second row, 3 columns. And then here 3 rows, 2 columns for the matrix 2. 3 rows, 2 columns, 10, 20, 30, 40, 50, 60. Then elements in the first matrix are 1, 2, 3, 4, 5, 6. Elements in the second matrix 10, 30, 50, 20, 40, 60 because we've accepted horizontally, and the product of matrices are 220, 280, 490 and 640. This is the matrix multiplication program. Let us see practice exercise here. This is about initializing the matrices. Just initialize 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4. And second matrix of 10, 20, 30, 40, 50. Initialize, multiply, and then display. So code for reading will not be there, just initialize and call matrix multiplication part and then display all the matrices. This is first matrix, second matrix, and product of the matrices. Refer chapter 7 of Essentials of Computer Applications for further understanding and practice exercises. The next video is about string handling in Java. Thank you.